In this session, we can discuss the most important problem related to the induction motor. First, we have a brief the note on the induction motor. That is, induction motor is a AC motor which will convert the electrical energy into mechanical energy by the principle of induction. That is the electromagnetic induction. But actually how it will works, which will works on the principle of rotating magnetic field. Here there will be a stationary part which it is called as stator, then rotating part which it is called as rotor. Then whenever the electrical energy is given to the stator conductor, which will produce the stator flux, then the stator flux is alternating in nature, then which is contact with respect to the rotor, then because of the short circuited conductor which will causes the current to flow, because of that current there will be a rotor flux will be produced. The interaction between the stator flux and the rotor flux will causes the mechanical energy, because whenever you are provided the power supply which will cause the current to flow, then it will produce the flux that will be linked with respect to the rotor conductor. Then this rotor conductor, whatever which is present in the rotor, will be get short circuited. Because of that reason, again there will be a cause of current will produce the flux. Due to that reason, there will be a possibility of the mechanical energy to be produced. Okay, this is with respect to the what, how it will work. Then what are the parts of the machine? That is stator, stationary part, rotor, rotating part. Then types of induction motors, that is with respect to the three phase. Based on the construction, there will be two types. One is squirrel cage induction motor, then another one is slip ring induction motor. These two are most commonly using in almost all the applications. Then we need to concentrate on the some equations which are to be related to that of induction machine. Here, with respect to the induction motor, first we need to concentrate on the what is the speed, that is the synchronous speed. The rotating part, if it is rotating proportional to that of supply frequency, then which it is to be called as a synchronous speed. That is ns is equal to 120f divided by p, which it is measured in terms of rpm, that is revolution per minute. What is f here? This is the supply frequency. It is measured in terms of hertz. Then p is nothing but it is the number of poles which is present in the induction machine. Then second thing which it is that slip. Here the slip is nothing but it is the difference between the synchronous speed and the actual speed, which is to be expressed in terms of the synchronous speed. That itself is called as the slip. Here ns is represent synchronous speed, the n is represents actual speed of the induction motor, which is also be measured in terms of rpm. But always the actual speed of induction motor is less than that of the synchronous speed because of the short circuited conductor in the rotor. Then actual speed can be get evaluated if you know the slip, that is ns into 1 minus s. Okay, here these three formulas are most important to solve the problems which is related to that of induction motor. Then other than that, here the whatever the flux which is to be get produced from the stator flux will be linked with respect to that of rotor, then obviously which will also be alternating in nature. Then because of that reason, the rotor flux will be produced. Okay, that rotor flux frequency, the whatever the current which is to be flowing in the rotor conductor will have a particular frequency. That frequency is proportional to that of the slip of induction machine. That is Fr is equal to S into F. S is nothing but slip of induction motor, F is nothing but supply frequency. Once you can go through all these formulas are to be used in order to solve the problem. Then we can concentrate on the problem which it is related to that of induction machine. Here the one problem which it is to be get considering here, that is with respect to the induction motor, that is a 3-phase 6-pole 50 Hz induction motor has a slip of 1% at no load and 3% at full load. Determine what is the value of the synchronous speed, what is the no load speed, what is the full load speed, then frequency of the rotor, then frequency of the rotor at full load. One is at standstill, then another is at full load condition. From this given data, what they given? First you need to concentrate on which type of the machine. First thing which it is that this is the 3-phase induction motor. The number of pole in induction machine is given as 6. Then frequency of the power supply is 50 Hz. Then what they given? The induction motor slip 1% at no load, that is no load slip S0 is equal to 1%. Then full load slip will be taken as SFL, that is the full load slip. Okay, that will be taken as 3%. But the percentage is the representation for the slip value, but the actual value is what? You have to divide that value by 100. That will become into 0.01, then 0.03. This is what the given data which is to be get provided from the problem. What you need to find? The synchronous speed, no load speed, full load speed, rotor frequency at standstill, rotor frequency at full load. Then first we need to concentrate on the rotor, that is the synchronous speed, that is ns is equal to 120f divided by p. What is the value of frequency? The frequency is 50 Hz, number of pole is 6. Okay, once you did the evaluation, then you will get the evaluation of the synchronous speed, that is 1000 rpm. Then they have given the no load slip, that is 1%. Okay, that is what they given. The S0 value they are given. Okay, with respect to that S0, you need to make the evaluation of what? The actual speed at no load condition. N0 is equal to Ns into 1 minus S0. What is the value of S0? That is 0.01. What is the synchronous speed? 1000. 1000 into 1 minus 0.01. Okay, how much you will get? 990 rpm. Then full load speed. They have provided the full load slip. Then according to that full load slip, what you have to evaluate? You need to make the evaluation of the speed of rotor, that is n equal to ns into 1 minus SFL, that is the slip at full load. What is slip at full load? 0.03, that is 1000 into 1 minus 0.03 is 970 rpm. This is the what? The full load speed. Then frequency of the rotor current at standstill. If the machine is at standstill means what is its speed? N equal to 0. What is slip? S is equal to ns minus n divided by ns. Then what happens if it becomes 0? Ns by ns. What is slip? Slip is equal to 1. Then rotor frequency you want. Then Fr is equal to S into F. Then what is the supply frequency? 50 Hz. Then 1 into 50 is how much? 50 Hz. Then what you have to evaluate? The full load frequency of the rotor. That is, they have provided the frequency at, that is slip at full load. What is that slip at full load? That is 0.03. Then Fr is equal to what? S into F. Full load slip you know 0.03, frequency you know 50. What is that value? 0.03 into 50, that is the 1.5 Hz. Okay, this is always the rotor frequency is less than that of supply frequency under running condition. That you have to remember. Okay, these type of problems will be asked 8 to 10 marks. Okay, so that these type of problems you can practice. These type of problems are most commonly repeating in the examination. Thank you.